Yes, sorry, I'm wrong there. So I hope now you're able to hear Mwalimu. So welcome to this very session. We are starting right away, my very good students. And this will be quantitative analysis. Quantitative analysis. Quantitative analysis. And this quantitative analysis I want us to look at today, I want us to start from the very beginning. We start from the very beginning. Yeah, topic number 1, mathematical techniques. Mathematical techniques. For those of you who have never seen these Mwalimu before, my name is Dr. Joshua Aura. I teach at RCM College, many papers at RCM College. I teach here. All right. So then I will be able to stop now my video for you to concentrate. All right. So this is quantitative analysis. And the first topic we are doing here is known as mathematical techniques. I hope now you are able to hear me, Pamela, better. What is happening today? Are you able to hear me better now? I don't know what is happening today. I believe you should be able to hear me better. All right. So we are looking at topic number 1. Remember, topic number 1 is known as mathematical techniques. Under mathematical techniques, your examiner wants us to look at 1.1, which is what here? The functions. 1.1, the functions here. So we start with functions. So we look. But first of all, you need to give me feedback whether you're able to hear me much better now. Please give me feedback. Are you able to hear Mwalimu much better? Please give me feedback. Are you able to hear Mwalimu much better now? Please give me feedback. All right. Thank you so much. Now we continue. So then we shall be able to look at what we call functions. And simply put, ladies and gentlemen, what is a function in mathematics? In mathematics, what is a function? Topic number 1, mathematical techniques, a function. So a function is a mathematical. A function is a mathematical relationship. A mathematical relationship where one variable depends on another variable. Depends on another variable. One variable depends on another variable. So in this case here, a function links. A function links independent variable, what we shall be calling variable x, versus a dependent variable, we shall be calling variable y. All right? Now, ladies and gentlemen, if, for example, somebody gives you a function of this nature, example, we have here y equals 3x plus 4. Y equals 3x plus 4. So automatically, this y, or rather this x, if I know x, if, for example, if x here equals 2, what will be the value of y, somebody? If x equals 2, what will be the value of y? If x equals 2, what will be the value of y? If x equals 2, what will be the value of y? Can somebody in this case here help me? If we're given a function like this, which is giving us a relationship between y and x. So if x is 2, y will be equal to, yeah, so we have here 3x plus 4. So my x is 2, 3 times 2 plus 4. What will be the value? What will be the value of y? And I wish all my students are able to talk to me very, very nicely, pretty fast, because I know they have calculators, without any hesitations. Without any hesitations, I will really, really, really be very happy if that happened, really. If that was to happen, I will really be very happy. I'm waiting. I'm waiting to get. Kibet gives me 10. Kibet has given me 10. Thank you so much. Thank you and thank you so much. So now you can see, if x today was to change, if x, for example, if x here was to be 5, then what would the value of y be? So then if I substitute here, my y will be equal to 3 times x now, which is 5, plus 4. Can somebody in this case give me this figure? 19. So we can see a change in x is causing y to change. And that is why, this is why the y is known as what here? Dependent. The y is known as dependent. Also dependent at times is called the response variable. The response variable like that. Because it responds to changes in x. It responds to changes in x. Now, as x takes a different figure, y takes up a different figure. My very good students, go ahead and give us a summary table of types of what here? Types of functions. So we have type, and then I'll talk of general form. So we start with the first one, which is linear. A linear function looks like this. Y equals a plus bx. Like the one that we had here is a linear function. That is a linear function. All right. And then we have number 2, what we call quadratic. A quadratic function in general form would be y equals ax squared plus bx plus c. Number 3, we have cubic. So cubic goes to what we call third degree. Cubic goes to third degree. This is first degree. First degree. You can see here the highest power is 1. This is second degree. The highest power here is 2. And then a cubic is third degree. degree. The general form here will be y equals ax cubed plus bx squared plus cx plus d. Then number 4, we have what we call exponential. An exponent is a power, where the power is a known, right? So if, for example, you have a function of this nature, y equals ab raised to power x. You can see now power x, unknown power, x not known. So this becomes an exponent. The x is an exponent. The function is known as what here? Exponential. The function is known as exponential. Then we have here, with your permission, number 5, we have what we call logarithmic. A logarithmic function basically will have one of the terms being in log form. It could be y equals log x plus 30x, yeah, plus 10. So long as at least one of the terms is in logarithmic form, then we call this one, yeah, very, very importantly, a logarithmic function. Let me get feedback. Have you been able to write up to where Mwalimu is? Anybody who has been able to write up to where Mwalimu has reached? Thank you so much. Then now, with your permission, I will proceed. Business applications. How do we apply these functions in the business world? So in the business world, we shall be able to apply these functions to ascertain revenue, where basically revenue will be price times quantity. Yeah, revenue will be price times quantity. You will see, ladies and gentlemen, if, for example, you are given, say, price is 10 plus 3x, and then somebody wants you to come and get revenue here, R. How do we get revenue? My revenue, anytime I want to get my revenue, I'll always take price times who? Quantity sold. So my revenue here will be equal to price, which is 10 plus 3x. I put this, this has to be put in brackets, times quantity, which for now is not known. So my revenue will be 10x plus 3x squared, like that. Very, very good. Very good for you to understand this. Very good for you to understand this. So we shall be using these functions here to ascertain this revenue function. Ladies and gentlemen, we shall also be using, in this case here, these functions for purposes of costing or cost function, where we shall be able to see that cost equals Vx plus who? Vx plus F. Cost equals Vx plus F, where V is variable cost per unit. Yeah. F is the total cost, total fixed cost. Yeah. And then, of course, we have X, as usual, the unknown quantity. And our C, the total cost, like that. So for costing purposes, all right? For costing purposes here, very, very important. So e.g., you'll be told here, cost equals 100x plus 1,000. See, this 1,000 is constant, doesn't have x. So automatically fixed cost here will be 1,000 shillings. Fixed cost there will be 1,000 shillings. All right. So this is a very, very good formula. Now, my very good students, please listen and listen to me very well. Where else do we apply this function? We have very many applications. Yeah, we shall be able to apply these functions for break-even analysis. Break-even analysis. Break-even analysis. So we know that at a break-even point, profit of a farm will always be equal to zero. At break-even point, profit is zero, or even losses, they are zero. Zero, zero. All right? i.e., at break-even point, revenue of a farm equals what here? Equals cost. We shall be using this for purpose of what here? Break-even point calculation. Is this break-even point a very, very important point in a business? Oh, yes. Ladies and gentlemen, as we shall be seeing later on when we start looking at each of these, we know that to get profit, which is pi, whenever you see pi in our case, pi is not 22 over 7. So pi is profit. And this profit will be 22 over 7. This is high school, right? Or what we used to say 3.1 for high school. For us here, pi will be standing for profit. And to get this profit, my good students, profit is revenue minus cost. So we are saying that at break-even point, revenue equals cost. Assuming we have generated 5 shillings, and then it costs us 5 shillings as well. You see, then at the end of the day, we shall be able to get profit of zero. Profit of zero. But will this really make me very happy as a business person? Why not? I will be very happy whenever I reach a break-even point, because break-even point shows a point of no struggling, where all the costs incurred by the farm are raised internally. They are generated, or rather, they are financed by internally generated revenue. Yes, I'm not making any profit, but again, I'm not struggling, because whatever expenses are incurring in the farm, automatically we are able to raise this money from the farm here by our sales. So break-even analysis is really important for all of us, my very good students. So basically, we are saying that a function is a relationship. A function is what here is a relationship. I hope you have been able to understand this. Now, my very good student, allow me, I'll be able to go straight away to these linear functions. Linear functions. So we have said linear functions are any function whose general form looks like this: y equals a plus what here? A plus bx, where b is the gradient and a is the y-intercept. A is the y-intercept, all right? And if you remember very well, to get the gradient, we used to take change in y all over change in who? Change in x. Change in y all over change in x. So then what will be told, ladies and gentlemen, is this. Or most importantly, note, to define a linear function, aka stands for also known as a straight line function. To define a linear function, we must be given any 2 points through which the line passes. Any 2 points through which the line passes. Any 2 points. It's a very, very important note. So, for example, with your permission, I'll be able to, with your permission, for example, find the equation. Find the equation passing through 1, 5 and 3, 9. You see automatically these are 2 points. So you know that A is this and B is this. Find the equation passing through 1, 5 and 3, 9. On a Cartesian plane, on a graph, whenever you have any graph like this, if this is point A, it will be given or defined by X and what here? X and Y. So whenever you see this kind of a point, know that this is X, Y. This second point, again the same, X, Y. Find the equation passing through. When you're told to find an equation passing through, 2 points, you'll know to remember very fast that it's only linear functions that are definable by you being given 2 points only. The solution is a linear function. And for us to be able to define a linear function, then we need to get the gradient b. And the b is change in y over change in x. So change in y, you can say 5 minus 9. Change in, or 9 minus 5, doesn't matter. 9 minus 5, all over change in x, which will be 3 minus 1. So 9 minus 5 gives me 4, all over 2. So meaning that the gradient here will be 2. The gradient here will be 2. Now, after we get, ladies and gentlemen, the value of the slope, we must come and remind ourselves of the general form. We want to get A. To get A, remind ourselves of the general form. And the general form is y equals A plus bx. And then in this case here, you choose 1 point. Because now we have one unknown, we choose 1 point. You either choose this 1, 5 or 3, 9. You choose 1 point. Let me choose 1, 5. I hope somebody would choose this 3, 9. We'll end up getting the same answer. So choose 1 point, and then now you substitute. Then substitute. So then we are substituting, ladies and gentlemen, here, please listen and listen to me very well. We are substituting here. We are substituting there. Very, very important. So I'm substituting this. So remember, this is x, y. So my y there is 5 equals A plus B. X, which is 1. X is 1. X is 1. And fortunately, we know the value of B. Fortunately, we know the value of B. So instead of you writing this B there, you can simply come and say 5 equals A plus B, B which is 2 times 1. All right? So then 5 will be equal to A plus 2, implying that A will be 5 minus 2. If you take this to the side, it will be minus. So A will be what there? A will be 3. Will be 3. So I don't know whether these ninjas are able to follow up to where Mwalimu has reached. Great ninjas of mine, are they able to follow up to where Mwalimu has reached? Yes. Thank you so much. Then once you have cleared Once you have been able to get A and B, now you come and write the function for us. You write the function. Our function is y equals A plus bx. So y will be equal to A, which is 3, plus b, 2x like that. You write down the function. Very, very important for you to be able to do that. Very, very important for you to be able to do that. And my very good student, in this very, very case, I would want you to appreciate what we call quadratic functions. Quadratic function. Second degree. Call them second degree polynomial functions. Also known as second degree polynomial functions. All right. Now, my very, very good student, for us to be able to get to these quadratic functions, first of all, we must know their general form. First, we must know their general form, which is y equals ax squared plus bx plus c, like that. That is the general form. Now, can somebody tell me this morning, how many points do I need to be able to define a straight line? Not a straight line, a quadratic function. How many points? We hear from you, and you have talked to this. 3. Already says 3. Already says 3. So linear functions, 2 points. Quadratic functions, how many points? 3 points. I hope you're together there. Are we together? I don't want to move with a very high speed. Are we together, really? Are we together? Thank you so much. So give me an example there. Thank you so much. At least we are together. We are together. Now, I would want us to have the 3 points, just the 3 points here, for purpose of us understanding. So, define a quadratic function that goes through the following points. So we have 1, 6, 2, 11, 3, 18. Remember, these are 3 points. Define a quadratic function that goes through these very what here, 3 points. Now, then what is up, the gentleman here? What you're supposed to do here is number 1, write the general solution, write the general form, of a quadratic function. General form of a quadratic function, of which all of us we are aware how it looks like. Oh, now y should be equal to ax squared plus bx plus who plus c, like that. That's what our y looks like. After that, step number 2, my friends, substitute the 3 points. So substitute the 3 points. We start with the point 1, 6. Remember, when it is written like this, you're supposed to recall pretty fast that this is x, comma, y. Substitute the general form, eh? So y is 6. So it will be 6 equals a into x is 1. So 1 squared plus b into 1 plus c. 1 squared is 1. So this will be 6 equals a plus b plus c, like that. Yeah, very important. So now we come and write this as a plus b plus c equals equation number 1. And now go to the second point, which is 2, 11. So point 2, 11. This point 2, 11, are you able to really do the substitution yourselves of the general formula? Don't forget that this is x, y. Now you're substituting in the general formula. You're substituting in the general formula. So then what do we have there? You see I'm substituting here. Y is 11 equals a into x squared, ax squared, plus b, x alone, is ever constant, like that. So meaning, ladies and gentlemen, that my 11 will be equal to, this is 4. 2 squared is 4. So I can't say a 4, 2. Mathematically, that will be wrong. I have to bring the number ahead. So it will be 4a plus 2b plus c, equation number 2. Then now form the last equation. The last equation is 3, 18. So you can come and write this if you wish. Say 4a plus 2b plus c was 11. That's our second equation. We have, ladies and gentlemen, point number 3, which is point what here? 318. Remember, we are substituting this in our general equation, which is y equals ax squared plus bx plus c. Yeah, my y, this is xy. 18 equals a 3 squared plus b x, which is 3, plus c, like that. So 18 will be equal to a times 9 plus b times 3 plus c. So meaning that 18 will be equal to 9a plus 3b plus c. Meaning that 9a plus 3b plus c will be equal to 18. Equation number 3. Then what are we supposed to do, ladies and gentlemen? Shall be able to solve all these equations simultaneously. Solve simultaneously. So we have our 3 equations, if you remember. We have a plus b plus c equals 6. Then we have 4a plus 2b plus c equals 11. Then we have 9a plus 3b plus c equals 18. So we have here, this is equation 1, equation 2, equation 3. Remember now here, you are supposed to eliminate one at a time. Like now here, it will be easier for us to eliminate c because you can see c is common, yeah, with the same coefficient. All right. So combine equation 1 and 2. So you combine two equations at a time to eliminate c. So eliminate c by combining equation 1 and 2. So you know I'm using elimination method, right? So I will do equation 2 minus 1. Equation 2 is 4a plus 2b plus c equals 11. A plus b plus c equals 6. I subtract to eliminate c. So for a minus a gives me 3a. 2b minus b gives me positive b. So then this c disappears. 11 minus 6 gives me what here? 5. Very important. Double underline this. So we have taken 1 and 2. Then you can take 2 and 3. Or 1 and 3, one is the same. You end up getting the same answers. I like taking 1, 2, and then 2, 3. Right? So again, we shall come here and eliminate c. Eliminate c by combining equations 2 and equations 3. By combining equations 2 and equations 3. Right? You can subtract them the way they are, but here I know 3 has higher coefficients. And to avoid negatives, I can say 3 minus 2. So first of all, I write 3. 9a plus 3b plus c equals 18. Then the other one is 4a plus 2b plus c equals 11. Again, you're limiting c through subtraction. So 9 minus 4 gives me 5a. 3b minus 2b, subtracting, remember, gives me b, equals 18 minus 11. 18 minus 11 gives me what here? 7, like that. Now we have this. So now we have our two simplified equations. We have our two simplified equations. First one was 3a plus b equals 5. And then we have 5a plus b equals 7. Fortunately, b and b are having the same coefficient. You can go ahead and subtract. You can subtract this minus this, or it doesn't matter really. So 3a minus 5a gives me minus 2a. Disappears. This gives me minus 2, implying that a will be minus 2 over minus 2. You give me what figure, somebody here? 1. It will give me 1. From these simplified equations, even that I've gotten a, I can get b easily by substituting. From this simplified, without I go to the bigger one, before I go to the bigger one, from the simplified equations, I can get the value of b. So what is the value of b? I'll pick any of the equations. 3a plus b equals 5. So 3 times 1 plus b, yeah, equals 5. Because we know a is 1. So, ladies and gentlemen, then this means that b will be equal to 5 minus 3. Which gives me what there? Which gives me 2. It gives me 2 like that. Having gotten a and b, I can go back to my very original equations to enable me get c. Enable me get c. I can go back to my very original equations. I actually work with this. Any right? All right. We have here A plus B plus C equals 6. So C, so we know that A plus B plus C equals 6. We have the value of A. A was 1 plus B, which is plus C, should be equal to 6. So this will be 3 plus C equals 6. Therefore, C will be equal to 6 minus 3. You want here? Okay, like that. Then now we write the equation. Remember, it was y equals ax squared plus bx plus c. Then my y here will be equal to a which is 1, x squared, so I'm replacing plus b which is what here? B was 2. So 2x plus c that I've just obtained here, which is 3. I can leave this like that, but you see mathematically, it's wrong to write 1, That one should be implied. So this should be x squared plus 2x plus 3. That is the answer. That is the answer. That is the answer. So I don't know whether we are still together. Are we really still together, my good students? Are we really still together here? Okay. And then, of course, later on, I'll be teaching you other methods of solving simultaneous equations. Yeah, we shall be able to zero into simultaneous equations there. But I just want to show you how, first of all, to get quadratic functions. Then, my very good students, please listen. Listen to me very, very well. Begging that you get to listen to me very well, so you can just get to finish this together in a very, very good way. All right. You really like QA. I'll be doing this like almost on a daily basis. What I don't know is whether you guys, are you working or you're full-time students? You get that feedback. That feedback is so important for me. Are you working or are you full-time students? Oh, some of them are working. Oh, most of them are working. Are working. Most of them are working. Oh, are full-time students here, ladies and gentlemen. There are no full-time students here. Let me ask you a question. Can we be stealing? Can we be stealing like your employers 45 minutes every day? Quite bad, but I mean, what do we do? After all, whatever you're studying, you need to benefit your employer directly. Directly. If you were to steal your employer's time, what do you think would be the problem with Sister Felicitas? Are you able to tell Sister Felicitas, please? Type there, tell Sister Felicitas, maybe to log off and then she comes back again. Or you have other classes. But fortunately at RCM, we record all our sessions. I believe by the fact that we are recording them, you can easily get the recordings in your learning management system. That is a beautiful thing with RCM. Obviously, somebody is typing for Sister Felicitas there to get off Zoom, and then she comes back. For somebody saying 8 to 9 will be very good. So she'll be working with that time, 8 to 9. Actually, I only need 45 minutes maximum. I need a lot of time. So, and then of course, those who would want to join RCM classes, do not hesitate. Our phone number is 0793 555 000. Yeah. Then with your permission, I will be able to write down here quadratic formula. LMS is still unavailable. Okay. We'll be able to discuss that quadratic formula. Quadratic formula. So if you're given here, we use this quadratic formula for getting roots. Use quadratic formula for termination. We shall talk about that. Let me just finish this session, and then we talk about that. Use quadratic formula to determine. Yeah, roots. Basically, there are two roots, what we call x values. Two roots. Remember that quadratic functions have a single turning point. A single turning point. Which could either be maximum or minimum. So like if this is minimum, we shall have the quadratic function cutting the x-axis twice. We have this is x1, this is x what here, x2. These are what we are calling the roots. We use quadratic formula to determine roots, the x values. It doesn't matter, even the other one, ladies and gentlemen, we were to still draw it like this, a maximum turning point, So if we were to capture it this way, a maximum turning point, we still have two roots, x1 and x2, like that. X1 and x2. So we have two roots, and we shall always use the quadratic formula to be able to get the two roots. One thing you're supposed to see here is that we are having this line cutting x values here. Y is exactly 0. Y is exactly 0. Remember, my very good students, I've just said here that y, general form, y equals ax squared plus bx plus who? Plus c. Yeah. But in this case here, but y now is 0. Yeah, y is 0. So meaning that for quadratic function evaluation, y is 0 equals ax squared plus bx plus c. Which I can write again, talk of ax squared plus bx plus c equals 0. This is a very, very important thing for us. This is a very, very important equation for us. And when ax squared plus bx plus c equals 0, then get x. We normally take minus b plus or minus b squared minus 4ac, everything we divided by 2a. Everything to be divided by 2a. This is what we call the quadratic formula. So if, for example, my good students were given here 2x squared plus 3x minus 2 equals 0, then what will be the value of x? First of all, I will identify the fact that this is quadratic in nature. And if it is quadratic in nature, then what do I need to remember? It's a quadratic solution that they need. Equal 0 means that they want us to solve. So x will be equal to 0. So then in this very case, I know that the coefficient of x squared is what we call a coefficient, is the number that comes before. So a is 2 there. And then I know b is the coefficient of x. C is the constant term. The constant term is minus 2, like that. So now, given this, I want to give you 2 minutes. Try your very best to give me the value of x. Given that now you have everything, including the quadratic formula here. Great. I will be able to substitute my good students. So I have here x will be equal to minus b. I'm following this. Minus b, which is minus 3, plus or minus b squared. You see 3 squared is 9. That's 4 times a times c, which is minus 2. Then everything to be 2 times a divided by 2 times a is 4. Then our x will be equal to minus 3 plus or minus. So please use your calculator to give me whatever we have in here. Use your calculator. You tell me 9 minus 4 times 2 times minus 2. What answer are we getting there, my good student? What is giving me this from their calculator? 9 minus 4 times 2 times minus 2. How I wish somebody was giving me these answers. $25. Somebody has told me that this is 25 all over 4. So this will be minus 3 plus or minus. Root of 25 is 5 all over 4. Wait. So then my x, see, because of this overriding plus and minus, we're going to have 2x values. The first value of x will be when I take a positive, over 4. Minus 3 plus 5 over 4. And this one will be equal to 2 over 4. 2 over 4 will give me what figure? 2.5. And then the second value of x will be when we take a negative here. It will be minus 3 minus 5 all over 4. Minus 3 minus 5 is minus 8 all over 4, which will end up giving me minus what here? Which will end up giving me minus what here? Second value is minus 2. The problem with most of us, they're not giving me answers. Remember, we should always provide answers to be able to understand this very well. Particularly, thanks for asking. Okay. Yeah. So this is pretty easy. Do you have your calculator with you there? Simply take 9 minus 4 times 2 times minus 2. Don't do anything with your head. Using your calculator directly. Say 9 minus 4 times 2 times minus 2. Jacqueline will be able to get me that figure as 25. Can you kindly confirm that, Jacqueline? As long as you have your calculator there. Otherwise, you see this will be the same as, there is this minus and this. Minus 4 times 2 is minus 8. Minus 8 times minus 2 is plus 16. So 9 plus 16 will be 25. But if you have a calculator, it is really easy directly. You say 9, even if it's a calculator from your OKR. Yep. So minus 2 like that. So then that will mark the end of today's session. Yeah. So in this case here, for those of you who would want to join RCM, this is our phone number, 0793 555 000. So if you have issues with your LMS, please go to your class and tag me on WhatsApp. Go to your class and tag me there. I'll be able to sort out those issues immediately. Otherwise, see you tomorrow at 8 a.m. Bye-bye.